Hi everyone, Assalamualaikum. In this video, we will discuss example 3 under homogeneous equation from first order ODE. We will discuss the question from previous semester papers. Solve the homogeneous first order differential equation given below. For xy dy equals to y squared minus x squared dx. Right, from here we have x to the power of 1. Y to the power of 1 means that we have degree 2 here. And then we have y squared and x squared. So this is also degree 2. So now we have same degree, which is degree 2. So this is homogeneous equation with degree 2. Right? To solve homogeneous equation under first order ODE, first step, we need to write dy over dx as a subject and name as equation 1. Alright, so from here, we can move dx to left hand side. Okay, so we get dy over dx. And at the same time, we can move 4xy to right hand side. So we get this. Okay, dy over dx equals to y squared minus x squared over 4xy. Right? Now, we success write dy over dx as a subject. So we can name as equation 1. Right? And after that, we continue with step 2. Substitute dy over dx equals to x dv over dx plus v and y equals to vx into equation 1. Okay? So after we substitute, so we get this. Okay? Let me check one by one. Okay? We substitute dy over dx equals to x dv over dx plus v. And then we substitute y equals to vx. Okay? We substitute here. Right? After that, we simplify this. So on the left hand side, we still have x dv over dx plus v equals to v squared x squared minus x squared over 4v and then x times x equals to x squared. Right? Then we continue with step 3. Factorize and simplify x squared. Right? So from right hand side here, we have term containing x squared in numerator and in denominator. Okay? All term in numerator and denominator has term containing x squared. Okay? So we can factorize and simplify x squared. Okay? On the left hand side, we still have x dv over dx plus y equals to, we factorize x squared, so we get times in bracket v squared minus 1 over 4v x squared. Right? Right. If we have a homogeneous equation with degree 2, we will succeed in factoring x squared. Right? If, let's say, we have homogeneous equation with degree 3, we will succeed in factoring x cubed. Right? So that's the pattern when we solve homogeneous equation under first order ODE. Okay? So now we succeed in factoring x squared because we are given homogeneous equation with degree 2. Right? So after that, we can simplify x squared in numerator and x squared in denominator. So after we simplify, we get x dv over dx plus v equals to v squared minus 1 over 4v. Right? So from here, we can solve separable equation. Okay? We continue with step 4. separating variables v and x, right? Alright, we can refer BODMAS to separate, okay? BODMAS is an acronym and it stands for bracket, order, division, multiplication, addition, and subtraction. If we want to solve a mathematical operation, we need to follow the order of BODMAS. But if we want to separate, we need to reverse the order. Means now we want to separate, so we need to separate minus and plus first. Alright, so from here, we need to move plus v to right hand side. Okay, so we get this. Okay, x dv over dx equals to v squared minus 1 over 4v. And then after we move plus v to right hand side, we get minus v. Right? Alright, from here, we can standardize the denominator on the right hand side. So we have v squared minus 1 minus v times 4v over 4v. Okay, and then we expand, okay, and simplify. Okay, so we get x dv over dx equals to negative 3v squared minus 1 over 4v. Alright. Then from here, we can move terms containing x and dx to right hand side, and we can move fraction containing v to left hand side. Okay, so we can move dx to right hand side, it become multiplication. Okay, and we move x here and it become denominator. Okay, and then we can move fraction negative 3v squared minus 1 over 4v to left hand side, so we can exchange numerator and denominator. Okay, so we get 4v over negative 3v squared minus 1 dv equals to 1 over x times dx. Okay, now we done separate variable v dv and variable x dx. Alright, so we can continue with step 5. Okay, step 5, we integrating both sides. Okay, from step 4 here, okay, we just put integration sign on both sides. So we get integration of 4v over negative 3v squared minus 1 dv equals to integration of 1 over x dx. Alright. Okay, from here, okay, we can integrate using this method. Okay, we can move out constant 4. Okay, and then from negative sign in denominator here, we can factorize negative 1. So denominator become positive 3v squared plus 1. Okay, if you want to check whether we factorize the correct function, okay, so we can try to expand. Okay, so we have 4 times v equals to positive 4, and we multiply negative 1 times 3v squared, we get back negative 3v squared. We multiply negative 1 by positive 1, we get back negative 1 here. Alright. Okay, then we can simplify 4 over negative 1 equals to negative 4. Okay, and then when the degree of numerator less 1 from the degree of denominator, we can integrate using ln rule. Okay, so if we differentiate 3v squared, okay, we get 6v. Okay, so we just put constant 6 here. Okay, and then to simplify back constant 6 here, we can divide by 6 here. Okay, so that when we simplify, we get back the above function. Right, and then from here, we simplify negative 4 over 6, so we have negative 2 over 3. And then when we differentiate denominator, and the answer is numerator, so the answer should be ln. Okay, when we integrate. Okay. Actually, for the right hand side, okay, we use the same technique. Okay, because when we differentiate x, it become 1. When we differentiate denominator, it become numerator. So the answer should be ln denominator. And same goes to left hand side. When we differentiate denominator, and the answer now is numerator after we adjust the constant. Okay, so after we integrate, it become ln denominator here. Alright. And then from here, we done integrate. Okay, so we can continue with step 6. Okay, we replace v equals to y over x because the original question is given in terms of variable x and y. So we need to replace term containing v into the form of y and x. Okay, so the general solution is negative 2 over 3 ln 3v squared. We replace v by y over x. Okay, and then plus 1 equals to ln x plus c. Alright, so this is the final answer. Okay, so we can stop here. Right, we no need to find the value of c here since the initial condition is not given. Alright, and before that, from here, actually we can integrate using u substitution. Alright, we choose u equals to denominator 3v squared plus 1. So we have variable u and variable v here. So when we differentiate, it becomes du over dv. We differentiate 3v squared plus 1, we have 6v. And then we write dv as a subject. So we cross multiply, so we have du over 6v. Alright. And then from here, 4 over negative 1 integration of v over 3v squared plus 1 dv. When we simplify 4 over negative 1, we have negative 4 integration of v over 3v squared plus 1 dv. Okay, now we replace 3v squared plus 1 equals to u. Alright. And then we replace dv equals to 6u over du over 6v. Right, and then from here we can simplify v from numerator and v from denominator, and at the same time we can move out constant 6 outside integration sign, so it become over 6 because 6 come from denominator. Alright, and then we simplify negative 4 over 6, so we have negative 2 over 3. And then integration of 1 over u du. So from here, we can integrate 1 over u du. It becomes ln modulus u plus c. Okay, and after that, we replace u equals to 3v squared plus 1. Okay, so the answer is negative 2 over 3 ln 3v squared plus 1 plus c. Okay, but we just put plus c on one side only. Alright, so we can integrate this function either using quick method here or using u substitution here. Right, we get the same answer. Coming up next, more examples for homogeneous equations. If you like this video, you can subscribe. Thank you for watching. Stay tuned. Bye. Assalamualaikum.